Algebra 2, Lesson 14, Finding Determinants. This is something that I want to take my time with because it can be complicated and we can struggle with it. And so I want to take my time going through it. We're talking about matrices again, right? We've talked about, so far with matrices, we figured out what a matrix is, right? It's a visual, different way of visually explaining data, right? We talk about matrices in terms of rows and columns. We have figured out how to add matrices. We figured out how to subtract matrices. We figured out how to multiply matrices, right? We understand rows and columns and what has to take place in either to multiply or do those two kinds of different things. And so today we're going to talk about something else, all right? Every square matrix, well, a square matrix means that it has to have the same number of rows as columns. So 2 by 2, 3 by 3, 4 by 4, 5 by 5. Obviously, okay, you can't have a mixed number, right? You can't, a 2 by 3 is not a square matrix, all right? Meaning that in order for me to find the determinant of a matrix, it has to have a main diagonal. We talked a little bit about main diagonals when we talked about identity matrices, right? Where it goes 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, if like it was a 3 by 3, right? And anything times identity matrix is my main matrix, okay? All right, so every square matrix is associated with one real number, which means we can take the data from this matrix and get it down to just a single number, one number. No matter how big the square matrix is, I can get it down to one single number, all right? And that's called the determinant of that matrix. If a matrix is not a square matrix, it does not have a determinant. We cannot find it. It has to be square, okay? All right. Enclosing the matrix with vertical lines designates the determinant of a matrix. It's a lot like absolute value in that sense. All right, so here on the left we have a matrix because it shows me that the brackets on either side of my data, 4, 3, 2, 5. But over here on the right, I'm showing that I'm trying to find a determinant by just giving those bars. Okay? So one shows me a matrix, the other one says I'm looking for the determinant. Okay? Determinant bars. All right, so hopefully, have I gone past anybody up to this point so far? Everybody's on board. We haven't actually done anything yet, but we're just trying to get our terms out there so we know what we're talking about. All right, heads going up and down. All right, let's look at what's next. Okay, what's next is how do we find the determinant? What is our process? I have yet, since my time teaching this class, seen where you've needed to find the determinant of anything bigger than a 3 by 3 matrix. So the smallest square matrix you can find is that we're going to work with to actually find is a 2 by 2. Right? If it was a 1 by 1, it's just whatever that one number is. Okay? So we do 2 by 2s and we do 3 by 3s. Okay? So with a 2 by 2, okay, the determinant of a 2 by 2 square matrix is found by subtracting the product of the entries in one diagonal from the product of the entries in the other diagonal. The order in which you subtract is important and is shown. All right, big complicated thing. Basically what we're saying is that the order, okay, is first I'm going to multiply top left by bottom right, always. Okay? Top left is first. Okay? Top left to bottom right. Oh, let's do this. Top left to bottom right. Then we're going to do bottom left times top right. Okay? That's second. And we're going to subtract. Here, let's pick a different color for that. We are going to subtract. Go ahead. Right, yeah, so if you wanted to see it like this, let's say you had A, B, C, D. What we're saying is it's going to be A times D minus C times B. Does that help you out? So, yeah, this was just an example where we would use numbers to find a determinant. So 4 times 5 minus 2 times 3. Just so you're seeing, okay, what is the actual determinant of this particular question? Well, the determinant is 14. Okay? Now, like with most things, especially matrices, Everything that I'm showing you can be done in your calculator, but I'm not going to show you how to do things in your calculator until you know how to do them pencil paper, okay? So not today, but another day, you'll figure out how to do this really, really quickly, okay? So does this make sense? Top left times bottom right minus bottom left times top right. All right, 4 times 5 minus 2 times 3, A times D minus C times B. All right. Now we're getting into how on earth am I going to do a 3 by 3 matrix? Okay. There are two methods to doing a 3 by 3 matrix. There's the expansion by minors and then a different method. I'm not going to take you through the second method. All right. And if you ask me why, I don't know that it's necessarily that the second method is harder, but it's not necessary for you to learn two ways. In fact, sometimes if you learn more than one way to do a problem that's already pretty hard, it's too much information. I'm going to end up confusing part of one with part of another, and I'm going to end up getting my answer wrong. So if I can nail down one way of doing this, I'm probably going to be more successful. Can we agree to that? Okay, good. All right, so there are two methods. The first is the expansion by minors. That's what we're going to do, okay? We're in the expansion by minors class, okay? If you pick an element of a matrix and cover its row and column, the determinant of the square matrix that remains is that element's minor. Now, I know there's a lot of wording there and you don't have any visual to look at. We're going to do that here in a little bit. So I'm going to explain everything that this is saying visually here in a moment, okay? To find the determinant, we multiply each element in one row or column by its minor, then combine these products by alternating between addition and subtraction, starting with subtraction. Let's go ahead and work out a question and show you how to do a 3 by 3 matrix, okay? Now, let's see. Let's, rather than picking one from like the question set, let's make our own 3 by 3 matrix and find a determinant. Okay? Numbers. I need numbers. Hurry. 3, 2, 5, 7, 4, 1, 5, 9, 12. Okay. All right, there we go. Okay. So now this is going to get really kind of jumbled. So I'm going to take this slow. Okay? The first thing that we're going to do is we're going to start with the number 3. We're going to start at the top left. Down here, I'm going to put 3. Okay? Now, what they said back earlier is that I'm going to eliminate this row and this column. Okay? You with me so far? All right. Now, do you see how I have a 2 by 2 matrix in here? Okay? I'm going to find the determinant of that matrix. So to find a determinant, I'm going to take 4 times what? 12 minus what? 9 times 1. Okay? We're going to do this whole thing out here. All right? And then I'm going to subtract. I'm always going to subtract second. All right? Then I'm going to do 2. Okay? So I've got a 2 here times, and I'm going to cross out this and this. All right? And this. Okay? Which means I'm left with, and I know I've crossed out the 7 and the 5 from the first time, but now I'm working with 7, 5, 1, and 2. I have another 2 by 2 matrix. All right, so I'm going to take, just because it might be hard to see, 7 times 12. Okay, do we see that? Yes? Jewel, yes? Okay, minus what? Minus 5 times 1. Okay, 7 times 12, 5 times 1. All right? And then finally, I'm going to do addition. Okay, we do subtraction and addition. Okay, that's just part of how it's done. I'm not telling you that there's, because of something that I mysteriously saw up here. No, this is the process. All right, what number should go after the plus? Anybody know? 5. I'm going to come to 5, and I'm going to cross out to the left. I'm going to cross out down. All right, so I've got 5 times, okay, 7 times 9 minus 5 times 4. Okay. Now, I need to go through and work out these parentheses, correct? Okay. 4 times 12 is 4 times 12 is 48 minus 9, right? What's 48 minus 9? 39. So I have 3 times 39. We're just going to leave that for now. All right, let's come over here. 7 times 12, is that what, 84? 84 minus 5, 79. So I have, okay, minus 2 times 79. Okay. All right, now we have 7 times 9. All right, so I've got 63 minus what, 20? So that's going to be 43. Okay, plus 5 times 43. Okay, let's carry this down here a little bit. Give myself a little bit more room to work. 3 times 39. 117. Okay, take your word for it. Negative 2 times 79. Negative 158. Negative 158. Plus, what's that, 135? Wow, I was way off. 215? All right, now I'm doing 117 minus 158 plus 215. I'm going to let you guys do that, right, because it's just subtraction and addition. You can plug it all in your calculator at one time. 174? All right, so 174 is the determinant of that matrix. Now, let's say I wanted to test this. I want to see if I'm right. Okay, this is where I'm going to show you how your calculator can do this. Okay? All right, so hopefully we can read these numbers. I've got a graphing calculator here. Let me find it that you can see. It should work exactly the same way your calculator works, but I'm going to use this to test it. Okay, just because we made up our own numbers and I can't go in the book and see if I'm right. All right, so what I'm going to do is I'm going to hit second, x to the negative 1, which is matrix. I want to edit, so I'm going to go over to edit to matrix A. And this is a 3 by 3, right? So I'm going to put in my numbers, 3, enter, 2, enter, 5, enter. It goes across the top row, and then it goes again by row, 7, 4, and 1, 7, enter, 4, enter, 1, enter, and we got 5, 9, and 12. 5, enter, 9, enter, 12, enter, right? We're all good there? All right, so I'm going to get out of this, second mode, second matrix, and I'm going to go over to math this time. Do you see how the first thing on the list is DET? What do we think that DET might mean? Determinant. So I'm going to hit enter. Now I have to go back in second matrix and select the matrix that I want the determinant of. I only have A, so that works out real nicely. I always like to close up my parentheses. Okay. And did our answer match their answer? 174, 174. Can the calculator do it a little bit quicker than I can do it?
Mine can't, because I can't figure it out.
Yeah, because you've got like the crazy calculator. I will try to figure out the whole TI and Spider. Yeah. So what I'm telling you, Axel, is do you know how to do a 3 by 3 matrix pencil paper? Yeah, so there's no excuse to not do it, even if it takes more time. Okay? And for you all with the graphing calculator, all right, I want you to be able to do this pencil paper. Your calculator is what you use to do what? Check your answer. Not to do it, but to check it. Okay? All right. Let's see if there's any questions we need to answer here. We don't need to do that question. This is all stuff from yesterday. All right, find the determinant of this matrix. Okay, we're going to do some of these. All right, we're on number 3 here. All right, what's my first step? Allison, number 3. If I want to find the determinant of negative 6354, what's the first thing that you're going to do? Negative 6 times 4. What comes after that, Angeli? Minus 5 times 3. Okay, good. Let's see, John, what is negative 6 times 4? Negative 24. Jewel, what is negative 5 times 3? Negative 15. Okay. And Axel, what is negative 24 minus 15? Negative 39. Okay? Negative 39 is my determinant. Okay? Are we feeling fairly comfortable with this? Here's the thing. If you can do a 3 by 3 matrix, there's no reason to not be able to do a 2 by 2. All right.
Well, 3 by 3 looks easy, actually.
3 by 3 does look easy after we do it, right? Because just so that we're aware of what we're going to do here, what's the first thing I do? Circle 5, right? Now what? Cross, right? The first one's always the easiest one because I don't have a whole bunch of lines yet. But what's nice about what we're going to do here is I'm going to be able to erase really easily, okay? And we'll be able to start over. So I'm going to have 5 times what? 5 times 10 times 0 minus negative 2 times negative 1. Do you see how many negatives there are there? All right, so what might be important so that I don't end up losing something? What did I do here that parentheses? Okay. All right, now let's clear that out. What do I want to circle now? Negative 3. What sign comes next? Minus, okay? Minus negative 3 times what? That always helps, right? 6 times 0 minus what? 1 times negative 1. Okay, now I'm running out of space, but what sign comes next? Plus. Okay, I'm going to come up here. I'm going to erase. What number am I going to circle? 2. Where do my lines go across and down? All right, so I've got 2 times what? 6 times negative 2 minus 1 times 10. Okay, you guys think you can handle that? All right, so good. Just setting it up is the first part to this. Okay, from there, I want you guys to solve it. Okay, tell me what the determinant is. If you guys can get the determinant right, then we will stop right here, and I will let you guys work. If you can do this, pencil, paper. Are you already doing it on there? Use it to check. Okay, I'm going to hit pause on the video so the video's not going super long for no reason. Just being silent. All right, we had a whole discussion here while the video was paused, but this is what we should get. Now, one of the things that is not, that you wouldn't have heard, is that out of the 1, 2, 3, 4, 5, 6, out of the 8 kids in here that did this with their graphing calculator, how many of you actually got negative 51 on your calculator? 1, 2, 3, 4, 5, which means we had 3 calculators that kept getting an answer of negative 57, even after we cleared the RAM, even after we double and triple checked everything that was in those calculators. So just so that this is clear and there's audio of it, you need to be able to do a 3 by 3 matrix pencil paper because your graphing calculator might still be wrong. All right, we're going to stop right there and let you guys work.